pull-out disconnect can be installed on a house for a lift station motor. The disconnect must be wired in accordance with the National Electrical Code. The cable used for the disconnect must be rated for the voltage and amperage of the lift station motor. The underground feeder cable, known as UF cable, used for the pull-out disconnect must be listed for underground use and have a temperature rating of at least 75 degrees Celsius. The UF cable must be sized appropriately for the load and distance involved. Firstly, the pull-out disconnect should be located in an accessible location, such as on the side of the house near the lift station. Secondly, the disconnect should be rainproof and weather-resistant. Thirdly, the disconnect should be labeled with the voltage, amperage, and purpose of the circuit. It is highly recommended that a qualified electrician perform the installation of the pull-out disconnect. Some local codes may have additional requirements for pull-out disconnects installed on residential properties. It is important to consult with local building officials to ensure compliance with all applicable codes and regulations. When selecting the correct wiring for a pull-out disconnect, you must consider the ampacity, voltage rating, and environmental factors to ensure safe and reliable operation. Ampacity refers to the current carrying capacity of a conductor, measured in amps. The selected wire must have sufficient ampacity to handle the maximum current draw of the lift station motor, along with any other loads connected to the circuit. Consult the motor's nameplate for its full load amperage, which will dictate the minimum ampacity requirement. The National Electrical Code Table 310.15 B16 provides ampacity ratings for various conductor types and sizes based on their insulation temperature rating and installation conditions. The voltage rating of the wire must be equal to or greater than the voltage supplied to the lift station motor. Residential electrical systems typically operate at 120 volts or 240 volts. Ensure the wire is rated for at least the higher of these two voltages to prevent insulation breakdown and potential hazards. Underground feeder cable, specifically designed for direct burial applications, is often used to supply power to the pull-out disconnect. UF cable is available with a voltage rating of 600 volts, making it suitable for both 120 volt and 240 volt circuits. The environmental conditions at the installation location also play a crucial role in wire selection. If the wiring will be exposed to direct sunlight, moisture, or extreme temperatures, choose a wire with insulation specifically rated for these conditions. UF cable is designed to withstand direct burial in damp or wet locations, making it a suitable choice for this application. However, if the wiring will be installed in conduit, you may opt for individual conductors with appropriate insulation ratings such as THHN or THWN. When determining the appropriate size for the conductors, consider the ampacity requirements, voltage drop, and applicable codes. The National Electrical Code provides guidelines for conductor sizing based on the load and distance involved. Voltage drop refers to the reduction in voltage along the length of a conductor due to its resistance. Excessive voltage drop can negatively impact the performance of the lift station motor, leading to reduced efficiency and potential damage. To minimize voltage drop, select a larger conductor size with lower resistance. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Use voltage drop calculators or consult with a qualified electrician to determine the appropriate conductor size for your specific application. The pull-out disconnect itself must be properly rated for the voltage and amperage of the circuit. Select a disconnect with a voltage rating equal to or greater than the system voltage and an amperage rating sufficient to handle the motor's full load amperage plus any additional loads. The disconnect should also be suitable for the environmental conditions at the installation location. If the disconnect will be exposed to rain or moisture, choose an M3R rated enclosure for weather protection. The pull-out disconnect must be installed in accordance with the National Electrical Code and local electrical codes. These codes provide detailed requirements for the installation of electrical equipment, including disconnects, to ensure safety and prevent hazard. Consult with a qualified electrician to ensure your installation complies with all applicable codes. Firstly, mount the disconnect in an accessible location, typically on the exterior wall of the house near the lift station motor. Ensure the disconnect is securely fastened to the wall and is protected from physical damage. Secondly, connect the wiring to the disconnect according to the manufacturer's instructions and the National Electrical Code requirements. Use proper wiring methods and connectors to ensure secure and reliable connections. Thirdly, properly ground the disconnect and the lift station motor to protect against electrical shock hazards. The grounding system should comply with the National Electrical Code requirements for grounding and bonding. The underground feeder cable must be installed at the proper depth below grade to protect it from physical damage. The National Electrical Code specifies minimum burial depths for underground wiring based on the voltage and location. Typically, UF cable must be buried at least 12 inches deep in residential areas. Before digging, contact your local utility companies to locate any underground utilities and prevent damage. Backfill the trench with suitable material, such as sand or gravel, to protect the cable from sharp objects. The installation of a pullout disconnect for a lift station motor requires careful planning and execution to ensure safety and compliance with applicable codes. It is highly recommended to consult with a qualified electrician to perform the installation. Some common mistakes to avoid when installing a pullout disconnect for a lift station motor include using undersized wiring, which can lead to overheating and potential fire hazards. Always select wiring with sufficient ampacity to handle the motor's full load amperage. Neglecting to properly ground the disconnect and motor can create electrical shock hazards. Ensure the grounding system complies with the National Electrical Code requirements. Improperly sealing the disconnect enclosure can allow moisture to enter, leading to corrosion and electrical failures. Use a NEMA 3R rated enclosure for weather protection. Failing to protect the underground feeder cable from physical damage can result in shorts and outages. Bury the cable at the proper depth and backfill with suitable material. Ignoring local electrical codes can lead to violations and potential safety hazards. Consult with local building officials to ensure compliance with all applicable codes and regulations. The benefits of installing a pullout disconnect for a lift station motor include providing a convenient means of disconnecting power to the motor for maintenance or repairs, enhancing safety by allowing for a complete shutoff of power to the motor, and complying with the National Electrical Code requirements for disconnects. A pullout disconnect is a safety switch designed to completely isolate an electrical circuit. It is a crucial safety device that allows technicians or homeowners to safely work on electrical equipment without the risk of electric shock. The pullout disconnect works by physically breaking the electrical connection, ensuring that no current can flow through the circuit. When the pullout is removed, it creates an air gap that prevents electricity from traveling, providing a safe environment for maintenance or repairs. Pullout disconnects are commonly used in various applications, including air conditioning units, heat pumps, and other appliances that require a dedicated disconnect for safety purposes. Firstly, disconnects provide a local means to energize equipment for maintenance and repairs. Secondly, they enhance safety by allowing for a complete shutoff of power. Thirdly, they comply with electrical code requirements. Selecting the right pullout disconnect involves considering several factors, including amperage rating, voltage rating, and environmental rating. The amperage rating must be equal to or greater than the full load amps of the equipment it is serving. The voltage rating must be equal to or greater than the system voltage. The environmental rating, such as NEMA 3R for outdoor use, ensures the disconnect is protected from the elements. Installation procedures are critical for ensuring the safe and reliable operation of the pullout disconnect. It is essential to follow the manufacturer's instructions in all applicable electrical codes. Firstly, turn off the power to the circuit at the main breaker. Secondly, mount the disconnect securely in an accessible location. Thirdly, connect the wiring properly, ensuring all connections are tight and secure. Fourthly, ground the disconnect according to code requirements. Fifthly, test the disconnect to verify it is functioning correctly. Regular inspection and maintenance can extend the life of a pullout disconnect and ensure its continued safe operation. Check for signs of corrosion, loose connections, and physical damage. Replace the disconnect if any issues are found. The location of the pull-out disconnect should be easily accessible for maintenance and repairs. It should be installed in a location that is free from obstructions and protected from physical damage. The disconnect should also be clearly labeled to identify the equipment it serves. When dealing with underground wiring, it is essential to use the correct type of cable and installation methods. Underground feeder cable is specifically designed for direct burial applications and is resistant to moisture and physical damage. It should be installed at the proper depth below grade, typically 12 inches, to protect it from being damaged. The cable should also be protected from sharp objects by backfilling the trench with sand or gravel. Always consult with a qualified electrician to ensure the safe and proper installation of a pull-out disconnect and underground wiring. They have the knowledge and experience to ensure that the installation complies with all applicable codes and regulations. Ignoring local electrical codes can lead to violations and potentially dangerous situations. Always check with local building officials to ensure compliance with all applicable codes and regulations. These codes may vary depending on the location and the type of installation. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years and provides detailed requirements for various aspects of electrical installations, including disconnects, wiring methods, and grounding. Following the National Electrical Code is essential for ensuring the safety and reliability of electrical systems. In summary, installing a pull-out disconnect for a lift station motor involves careful consideration of wiring requirements, disconnect ratings, installation procedures, and applicable codes. Consulting with a qualified electrician is highly recommended to ensure a safe and compliant installation. Proper maintenance and regular inspections can extend the life of the disconnect and ensure its continued safe operation. By following these guidelines, you can ensure the safe and reliable operation of your lift station motor and protect your property from electrical hazards. Remember safety first and always consult with a professional when dealing with electrical installations.